Welcome to lesson 9, mergesort. This algorithm will split the data structure into multiple chunks. Then it will sort each one of these chunks and then it will merge all the fragments together. This diagram will help you understand how the algorithm works. That's the situation when the number of items is not a power of 2. You should be able to figure it out the remaining patterns by yourself by looking at this one. Now we have the very first chunk on the left, and 12 and 5 now are going to swap. 1 is going to join this group. One more group over here. 10 and 7 will swap. 9 will join. Now we have a big group on the left. Now we have one more group on the right. 4 and 3 will swap, and 11 will join. 8 and 2, same thing, swap. And then 6 join. And then we have one more big group over here. And then eventually these two big groups will merge. Use it to sort small arrays as it runs faster than all previous proposed sorted algorithms. However, although highly parallelizable, it does not scale very well as it creates a copy memory of the array that has been sorted. Let's build the code with debugging symbols. And then let's run it. Okay, initial array. Let's have a look at the source code over here. 12, 5, 1. That's okay. Sorted array. It worked. So we can start the debugger. Then we set the breakpoint. We want to debug the test class. Then we want to stop right here, 84. Then we run the class. Monitor list. So every time we issue a command, we will know where we are. And then step. Okay, we're about creating the array that we're going to be using to sort the chunks. That's so good. Step. So we're about entering the method that we will use to split the array. Okay, now are we done with the partitioning? Well, not really, because left is 0 and right is 11, so we just started. Step. Okay, this is going to be, I want to show you this. This is 5 because we are dividing using 2 integers, so the decimal part is going to be ignored. And then step, split array, so recursively calling itself, passing the bottom half. Okay. Now locals, we have 0 and 5, so long way to go. Now we are here again. Print init. Well, there was 0 plus 5 divided by 2, which is 2.5. Once again, we won't get the 0.5. So we continue. And then locals again. That's 0 and 2. So in again. And then it's going to be 0 plus 2 divided by 2, which is exactly 1. And then we are here, split array. Once again, we are splitting the array and step. Now locals, we have then 0 and 1. Not yet. So one more lap. And this is 0. Because 0 plus 1 divided by 2, which is 0.5, and once again we ignore the 5. Step. Okay, now we are done. We are here. So we have the locals, we are calling the split array having mid plus 1, which is 1, and right, which is 1. Okay, locals 1 and 1, that's supposed to be exiting. And finally, we start sorting the data. Sort the chunk that starts at index left and ends at index right. So, which means that we're sorting the array starting at 0, ending at 1, which is 12 and 5, right? If we do dump of the data array, these two values over here. Okay, so step, we are entering. Okay. Okay, now if left pointer, which is 0, is less than mid, which is 0, less than or equal, and mid pointer, which is again 1, is less than or equal right pointer, which is 1, yes. So we are in. Now if yes, 12 and this one over here. So if left pointer, which is 12, is less than 5, do this, otherwise do that. So we're going to be doing this. Okay, we are here. So we have that, dump. Now it's empty. Now we do it again. 5. So we start building the sorted version of the array, although this is still the core. Don't forget that. And again, the cycle. Okay, so we do dump copy of data array 12 and 5. Now let's see what happened, and also dump data array. So this is not sorted yet. This is the actual array that needs to be sorted. So let's see what happened here. So we do step and step and step. Okay, now if I print the actual array, now if you look at the slides, you're gonna be noticing that it's exactly following the pattern that I've explained before, right? The very first two items are ordered. Now let's see what happened with this 1 and this 10 and 7 over here. Now we are splitting the array again. Locals 2 and 2. Okay, the method can exit. Sort again, and we are calling the sort knowing that we are passing left with 0 and 2. So dump data array 0, 1 and 2, right? Over here, step, and again we are doing the actual sort. If left pointer and less than or equal to mid, blah blah blah, like before, right? Step. And now if this, is less than this one, which is not true. Do this, or otherwise do that. Okay, we are here, so we're gonna have this one over here, okay, one, copy data again, and what I want to show you now, if I dump copy of data array 1, 5 and 12, so as explained before, is the one that joined the chunk. Now dump data array 5, 12 and 1 is still not sorted, and what this instruction does is actually copying the chunk that is sorted into the actual array, as we've seen before. Nothing new. Now step, okay. Now dump data array, and it's done. Now step again, and then step, and then step. Okay. Okay, now we are calling the sort again, and the edges will be print left and print right. So if I do dump data array, it's gonna be 0, 1, 2, 3 and 4 as expected, and so on. I hope you've enjoyed this class. Thank you very much.